Hi everybody, let's go ahead and get started. My name is John Messick and I'm here with Kurt, Amit, and Madhu, and we are going to be presenting Troubleshooting Virtual Machine Manager 2012 SP1. And we really appreciate you guys coming out to one of the last sessions of the event. I know that it's probably really tempting to kind of bail out early today, so really appreciate you guys showing up. Do want to give you a little bit of heads up front that there's going to be some digging into trace files and some low-level debugging, so if that's not your thing, feel free to kind of hit the door now, but there's also going to be some high-level information as well. So today we're going to cover a few primary areas. You know, there's a lot of different areas we could cover with debugging VMM, and we obviously can't cover near all of it in a 1 hour session. So we're going to hit on a few key areas. We're going to talk about the distributed architecture of VMM, as well as some of the architectural elements with storage, how you go about setting up tracing and logging to do some basic debugging and troubleshooting. And then we're going to dig in and look at some specific issues around host communications, storage, as well as software-defined networks. Then at the end of this deck, if you want to download it later, there's some information about where you can go to get more information, wiki and so forth. So first of all, tools and tips. Just hit on some general things real quick. This is really high level, kind of basic stuff, but you know, it's helpful. Sometimes people skip this stuff. First of all, make sure that when you install VMM that you keep it updated. The product team has been working really hard to keep abreast of any issues that come up and get fixes out there very quickly. So if you run into something that's a product issue versus a configuration issue, there's a good chance that it's either been fixed in a recent update release or that it's in the process of being fixed. So keep everything updated. Understand where the key application and event logs are on the systems, both on the VMM server as well as the hosts. And we're going to dig in a little bit more about how you can capture some of those logs later on in this session. Ensure that the servers can communicate with each other. That's also going to be covered in more detail later. Another common issue that people have is make sure you have the right run-as accounts. For instance, when you're provisioning storage for certain scenarios, you got to have the run-as account as local administrator. Now, VMM will let you know that it'll give you an error that, hey, you don't have permission, but you know, a lot of times people are running through and kind of miss some of those errors. So pay attention to what VMM is showing you. Really high-level stuff, but you know, just got to get that out of the way. So there's also some great tools out there. Microsoft Baseline Configuration Analyzer that'll look at your environment and give you some of the most common troubleshoot some of the most common configuration errors. Just you can download that from the MSDN site. So first thing I want to talk about in detail, ETW tracing. Just kind of get a feel here. How are people in the audience familiar with ETW tracing? Do you know what that is? Have you used? Yeah, Alvin. Have you used it quite a bit? Okay, doesn't look like it. So ETW tracing is event tracing for Windows. A little bit of history of that is that since I believe it's since Vista. Much of the underlying eventing of Windows has been built on this mechanism. Log files are built on ETW tracing. The event viewer is built on ETW tracing. And in the last couple of releases, VMM has also moved to use ETW tracing. So if you go out and search for how to turn on troubleshooting and debugging for VMM, you're going to see a lot of information about ODS flags and so forth. Now, all that still works, but there's newer and better ways to do that. So when you go and use the ODS flags methods, there's things you have to do with setting up registry and restarting services and so forth. Great thing about ETW tracing is you don't have to do that. It's also much more performant. The logging that it provides is actually in a binary format, so it's not doing string formatting and writing these huge logs when it's doing tracing. So you'll take much less of a performance hit. And it's also very fine-grained. There's a ton of trace providers available in Windows, not just from VMM, but from Hyper-V, WinRM. There's a whole list of them, and I'll show you how you can get the information about which providers are available. Now, the way ETW tracing works is, at a really high level, is there are these things called providers, and there are these things called listeners. Now, a provider, VMM is an instance of a provider. It will, if there's listeners that want to hear our event traces, then it will just spew it out to to one or more listeners. Listeners, on the flip side, are the things that listen and create logs. And listeners are really easy to create, and when we go through a demo in a minute, I'll show you how to create one of those that will listen to events on VMM. There's a couple of tools that are built into the box that allow you to create these event listeners as well as look at the logs. Even though they're in binary, there's a way that you can basically expand them out into human readable form. So logman.exe is the first command line utility that we're going to look at. And I'm going to just kind of hold off on the details here until we get to the demo. But that'll allow you to query providers, register providers, set up really fine-grained, interesting ways to run the providers, such as setting up circular buffers so that you can run your event listeners indefinitely without filling up your disk. You can also set scheduled event listeners. So, for instance, one of the things you can do is say, I want this event listener to run from midnight to 2 a.m. on every night and not listen the rest of the time. So that'll really shrink the size of the log files that you generate. There's also a bunch of flags that you can set for verbosity level. So you only want critical errors, you want warnings, you want all verbose tracing. And the next piece that we're going to look at is netsh. So as I mentioned, the ETW traces are in binary format, and so these come out into an ETL binary file. There's command line utility netsh that you can run to take that and merge it with localizable, human-readable string information and generate basically a text file of your log. And there's also some other tools that you can run to get a graphical interface to kind of explore those logs. So first thing I want to do is show you how to use it. So I'm going to switch over to my computer here. So first thing I'm going to do is use Logman to see what kind of providers are available on this system. So it's as simple as doing logman query providers. And this takes just a minute to run, so I'm actually going to open a text file in which I captured this previously. And you can see it's actually just running in the background there. But there is a ton of them. So anything you learn about capturing traces here for VMM, you can also apply to any number of other pieces of the system. WinRM, WMI, Hyper-V, those are some of the more common ones that you'll probably be using when you're exploring some of your troubleshooting situations. So if you look in the log file here, VMM is registered as Microsoft Virtual Machine Manager Debug. Now there's a couple of others here. These are they're available in the system right now, but they may not be in future releases. They're sort of transient. The -debug one is the one that we'll be carrying between releases. And if you really want to be robust about it, you would use the GUID. When you register to listen to these providers, you can either provide the GUID or the friendly name. So I'm going to go back to command line, and I'm going to create a listener so that I can generate a log file from VMM. So I go logman, create trace, and I'm going to call it my VMM. It's just whatever name you want to give it. And the output file that it spews to will be my vmm.etl. And the provider I want to listen to is Microsoft Virtual and it completed successfully. So if I just type logman by itself, it'll show you the currently registered listeners. So there's 3 of them on there now. One of them is the one that I just created, and that's my VMM. and it gives you the current state of it. So even though it's created, it's not generating logs right now because it's stopped. I have to actually either manually start it or schedule it to be started. So I'm going to go ahead and start it now. So that's as simple as doing logman start my VMM. Oops, already got have some old log files in there. Looks like I got a locked file somewhere, so I'm going to just create another event listener with a different name. My VMM2. Now I'll start that guy. Logman start my VMM2. Now if I do a dir, we can see that there is a my VMM2 and then a big long incremented number .etl. And it's zero size right now because there's nothing been written from the buffer yet. However, it is logging. So if I switch over to VMM, and I'm just going to do something like restart a server or power off server. Now if I look at the directory, it's still zero size. And the reason for that is because ETL is really about performance. And so it's not going to write traces to disk every single time something happens. It's actually buffered. But as soon as I stop the trace or as soon as it fills up to a certain point, it'll start writing that out. So if I just do logman stop my VMM2, so I'm going to tell it that I've hit the problem that I want to look at the trace for. I'm finished logging, so stop logging. Now if we do a dir, we can see that the my VMM2 trace is non-zero size. There's actually data in there. Now, if you remember what I mentioned earlier, it's not human readable. It's just a binary file, so there's nothing we can do with it right now. So we want to convert it to something human readable, and that is done using NetSH. And there's some other tools that you can download from Microsoft that allow you to do this with a GUI and everything. But a lot of times it's really useful to be able to just use the tools that are on the box. So we do NetSH trace convert, and we give it the name of the ETL file. Oops. And you can see that it said it generated a text file. If we do a dir, we see the text file here. And we can open that guy up. And there's our nice trace that we just captured. And it's got a lot of information in it, so some of these columns probably aren't interesting to you, but there's some process ID information, a thread ID, so if that's helpful to help you go and filter out the massive amount of debugging information to a specific processor thread, then you can use that. And if we scroll over to the right, you can see that there is indeed nice human readable and in fact localizable debug information. So that's the basics of using ETL to do tracing. And again, this can be used for pretty much any piece of the system that you want to look at tracing for. You won't always get human readable information. It just depends on whether or not the ETL trace resources have been published or not. So sometimes when you run that conversion to get the human readable form, you'll just get some data columns without human text descriptions. Just depends on which application it is you're tracing. Excuse me. So, as I mentioned, this is using the tools on the box. There's also tools that you can download. MPS reporting tool is a really nice one. This is primarily for VMM, System Center VMM 2012 and not SP1. They're currently working on some other products to take the place of this. So if you run it on an SP1 system, some of the trace formats are different and you're not going to get really good results. But if you're still running VMM 2012, it's a great tool. And what this does is allows you to configure via UI, and it's pre-configured to log some of the more interesting VMM pieces, VMM, Hyper-V, bits, WinRM, cluster, and WMI. It also allows you to do it across multiple machines, but in essence, this application here is just built on the tools that we just did in the command line. Everything you can do here, you can do in the command line. It's just you have to know the commands. I can actually set up remote logging fairly trivially, actually, and capture from multiple machines at once. So the next piece that's in that same package, it gets downloaded with MPS reporting tool, is traceviewer.exe. And this is a really cool application because you can open an ETL file directly and it'll do the merge itself and give you a GUI front end for looking at logs. And it's got some really neat things on it, like you can do filtering, you can filter on like VMM task ID, and you can do searching. It's just a lot easier to work with than a raw text file. And I'll show you how to set that up when we do the next demo. One thing to keep in mind when you're looking at these logs, it'll become obvious pretty quickly, but it's top down. So if you're looking for an error that occurred within the time period that you were doing your tracing, start from the bottom of the file, and search upwards. So if you're looking for a keyword error or exception, start there, because if you start from the top, you'll likely get a bunch of noise that you're not really interested in. So go back to my demo box. And I'm not going to really do much with it, but I'm just going to show you the tool and some of the MPSRT tool. So as you can see, it's already connected to the local host, and I can very easily just come in and say, oh, I also am interested in logging to con Hyper-V 7. And I can go in and run enable tracing for multiple pieces of VMM or multiple pieces of the system simultaneously across multiple systems. And like I said, I'm not going to do that right now because this is all SP1, and only certain of the commands work, because it's really this piece is meant for 2012, not SP1. However, if you are using this, it's really neat that you can, after you've run your tracing, you can run collect and just say collect all, or you can do collect advanced and just say that I'm interested in getting debug traces for a very specific time range. And when you do that, it will go out and grab those logs and generate a zipped package that you can use for sending to support or sending to somebody. If you dig into here, it's got a set of logs for every single machine that you were tracing on, just really nicely packages them up. And for each of those, it'll have each of the components that you were tracing. So, a couple more general troubleshooting tips. If you're hitting a problem in VMM, try reproing it in PowerShell, because we've done a really great job of cleaning up and doing a lot of work with the current version of the VMM GUI. But it never hurts to check to make sure it repros on the command line. That'll help you isolate where the problem is. If it does repro in PowerShell, check to see if it repros independent of VMM. So there's a lot of issues that you can really skip a lot of debugging steps if you go straight, for instance, to Hyper-V, and you can repro the problem there. If, for instance, you're not able to start a VM remotely and you go to Hyper-V and you're not able to start it locally directly from Hyper-V, that's going to cut out a lot of middlemen for your debugging issues. Don't discount the jobs view. A lot of times people miss the fact that there is fairly rich information in the VMM jobs view, along with subtasks. It'll really help you narrow down quickly. Look at the trace logs that we just talked about. If you're reproing hard to hit issues that may take a while to repro, be sure to set up circular buffers, and Logman makes it very easy to set those up, and you just look at the command line parameters and you can see how to do that. You can also schedule it, like I mentioned earlier, if you're hitting issues in the middle of the night when load's particularly heavy or something, just have the logs generated during that time period. No use running them 24 hours a day. Okay, VMM agent communications. So VMM deployment is, as we know, it's fairly complex. There's a lot of moving pieces. We've got VMM servers, we've got library servers, we've got the client, we've got multiple Hyper-V hosts, we've got VMs on those hosts. We've got agents on all these guys. So it really helps to keep this view in mind as you're debugging to understand where the communication paths are. There's a lot more that I'm going to show you in this slide here, but these are some of the major communication paths. We talked to ADO.NET to SQL Server. From the client, we're talking PowerShell, we're talking over WCF. WinRM's used all over the place. We use bits transfers for moving things between systems. So just try to understand which communication mechanism. And if you go online, there's a very exhaustive set of information about this. You don't need to kind of memorize it here. WinRM, you're debugging WinRM. So is it enabled on all the systems? Oftentimes it hasn't been set up. There's a quick config that you can run with WinRM that'll get rid of a lot of the major problems. Are you having firewall or proxy issues that aren't letting communications through? Are your ports configured correctly? Are you having permission issues? So these are some of the most common areas that people hit issues with when you lose host connectivity or WinRM's just not working right for you. When you're adding hosts, ensure that you have correct credentials, that you can see the admin share. CredSSP is another interesting one because often it's disabled by group policy. So make sure that if you're having issues, there's not a group policy setting that's overriding anything you're trying to do and basically shooting you in the foot. So let's go back to demo box. So I'm currently on the VMM server, and I'm going to start tracing. So logman start my VMM2. So now we're running tracing, so any kind of errors that occur, we can go back and look and see what happened. So now I'm going to switch to VMM. And I'm going to run a refresh on this guy. Or let's see, what else can I do? Yeah, do a refresh. And the job failed. I wonder why that failed. So let's go back to our command line. And stop tracing. So I'm going to, this time, open the current directory in, oops, sorry, I'm in the wrong directory. I'm going to open the current directory in File Explorer and show you that earlier I mentioned that there's a graphical tool to look at traces, Trace Viewer, and I've gone in previously and associated .etl files with Trace Viewer so that I can just open them up straight from here without having to do that manual conversion step. So now if I look at the ETL file that we just generated, when we hit that error, it's going to go in and ask you where to save the text version of it, and it brings it up. So now we have a nice graphical view that we can come in here and search for error, for instance. We can see we get any number of these guys. And this log file itself isn't really large, but you can imagine that sometimes you'll have many, many, many hundreds of megabytes of log files, and so it gets to be sort of very hard to dig through and find the problems you're having. So another little trick you can do is if you go back to VMM and look at the jobs view, at the last failed job, notice that there's a task ID over here. Unfortunately, you can't copy and paste that task ID directly, but you can copy and paste the whole line and open it up in Notepad. What I'm trying to do here is grab that task ID so that I can filter on it in Event Viewer. So just copying the task ID to the clipboard. lost my place. Hold on. Okay, so like I mentioned, one of the things you can do is do filtering. So I'm going to do a task ID filter on this guy. I think I actually have the wrong one open. So probably going to get blank, yeah. There we go. So I'm going to filter on task ID, and that'll allow me to get a much smaller view. So now the only tasks I see in the log are the ones, the only trace elements that I see in the file are the ones related to that task that ran. And so it's much cleaner, much easier to look and see exactly what happened. So in this case, obviously, you can tell from the failed job information directly in VMM, so it's not too difficult, but you can see that we actually had a WSMan WinRM error. So host agent connection failed. So we should probably go debug that. So the first thing I would do is, this is basically equivalent to a ping in WinRM. So do WinRM ID, and that'll give me local information about the local instance of WinRM. And we can see that it does indeed give us useful information, which means WinRM is running. WinRM also has a -r command, which we can run against a different server. So I'm going to do HTTP. I'm going to run it against the host that I can't communicate with, and we're running on port 5985, which is the default port for WinRM. And we get a lot of red, which means that even at the command line here, we cannot talk to WinRM on that box. So I'm going to switch over directly to that box, and I'm going to do WinRM ID on this guy to see if WinRM is running at all. And it looks like it's running okay, so I'm going to see if I can ping it remotely from itself, and that'll let us know whether or not there's some firewall issues between us and the other machine. So if I can ping it remotely from basically loop back to itself, then we know that the issue is probably somewhere else besides on the box here. So do logman, WinRM. And it also fails. So there's some other problem going on. Next thing we can do is get a little bit more information about WinRM running on this box. So we can do a WinRM enum. WinRM config listener, misspelled it. And that'll give us a little bit more information about the listener on here. So we can see that it's listening on these IP addresses, and I know that those are the correct ones that should be listening in onto. It is enabled. It transports HTTP. Problem here is that it's on port 1234, which is obviously wrong. We want to be on port 5985. This is obviously a very contrived example, but it kind of shows you some of the steps that you go through when debugging this stuff. So I'm just going to do a real quick setting that to the correct port. This command here is not really important for the purposes of debugging. All I'm doing is telling WinRM that, hey, now we want to go listen on port 5985. And in fact, it's now listening on 5985. So let's just check again, see if we can hit it remotely from itself, and we can. So if we go back to VMM2, and try to ping it, it does indeed work. So last thing is go back to VMM. Let's try to rerun the job, see if it works. Oh, unfortunately, I did a non-restartable job, so I can't really show you that. But let's see if we can actually do another command on it. And it completes successfully. So we successfully debugged that. This was a very, very trivial example, but it shows you some of the thought process you should go through when you're debugging some of these host connection errors. So at this point, I'm going to hand this off to Madhu, and he's going to talk to you about troubleshooting storage.
Hello all, good evening. Today I'm going to cover troubleshooting storage. Before going into troubleshooting storage, I just want to give overview of storage, some features of the storage, and then what are the components involved in storage management so that we know how to go and debug this information. So I will cover all the components and the architecture perspective, and right after that, I will hand over to Amit, who will give example of a couple of scenarios, real-world scenarios, and then how to debug storage aspects. So, right, VMM itself, compared to last three releases, we have introduced quite a bit of functionality in storage. If you look at earlier in 2008 or two before, we used VDS hardware providers from hardware vendors, and then basic thing we did was SAN migration, VM SAN migration. That's the only functionality which was available. Moving from that, in VMM 2012, we moved into standard-based SMIS-based storage management, block storage management, using which you could basically manage the storage starting from discovery, provisioning aspects. In VMM 2012 SP1 with Windows Server 2012, this became part of the operating system itself, using which now with Windows 2012 you can manage storage directly, and then VMM hooks onto that. And not only the block side storage management, we also introduced file server management too in SP1. So functionality-wise, totally what we have is from block side storage management, you can do end-to-end mapping. That means from virtual machine to VHD, VHD to specific volume on a host to disk, and then from disk to you can map to specific LUN on the array, and then LUN to pool and pool to array basically. So you can go work from end to end. So the piece of information we get is from the providers and then also host side to build this end-to-end mapping. So that's not only limited to end-to-end mapping, but we can also do provisioning. For example, you can stand up a CSV for a cluster. So we will create a brand new LUN, and then you can unmask a storage to all the nodes in a cluster, and then also make it as a CSV. So that for virtual machines, you are ready to consume it. And then there is a rapid provisioning where you can use a SAN snapshot or clone functionality to rapidly provision virtual machines using SAN sphere cool features. That is on the block side. But on the file side, which we introduced in SP1, where not only we manage files, Windows file server, but also NAS-based third-party SMIS-based, for example, EMC and NetApp arrays for SMB3. So here on a file server side, we do discover shares on the file server from the SAN side, and then also we can create shares and then also do ACL management. So that's just to mention we have a few, but there is a lot more functionality where previously we had a talk from Hector, which he covered a lot more information. So now for this functionality, what do we do? This is the storage architecture, which I want to explain. So here is a VMM server managing Hyper-V hosts, one or many Hyper-V hosts. They're all connected to fiber channel or iSCSI target. So this one talks about only block side management. So VMM uses currently what is called is a SM API. SM API is a storage management API introduced in Windows Server 2012, using which you can do block storage management. It's a WMI-based API, high-level abstraction, and it is standard-based API. I will go more into details of that, but using this API, what you can do is you can discover array, pools, LUNs, and then also create and delete LUNs and do mask, unmask, and then also snapshot and the clone creations. So those are the functionality. From the host side, for a Hyper-V host or a cluster, we use a bunch of APIs on the host side to manage. First thing is for discovery. You should be able to discover what disks and volumes are present on the host. For that, we used to use VDS earlier. Now, with Windows Server 2012, we started using host-side SM API, which is WMI-based. VDS was COM-based, but SM API is a WMI-based. That gives the disk and volume management using which you can do format, create partitions, and then anything with a mount, unmount, and stuff like that. And then the other one is for iSCSI. iSCSI, we use Microsoft iSCSI Initiator WMI APIs, using which you can do login, log out, and then discover portals and all iSCSI session management. For the fiber channel and the SAS, we use a standard-based HBA API, which is also WMI based, but it calls standard-based HBA APIs, using which you can discover HBAs as well as port information, and then also what LUN's been unmasked to these HBAs. And then finally, the clustering, because cluster WMI is also very important, as if you have to stand up a CSV after unmasking a LUN, we go use cluster API to add a disk resource and then also make it as a CSV. So these are the APIs which cover on the host side, only specific to storage. But again, there is other APIs such as Hyper-V APIs and stuff like that for the VM management. Here only I was covering on the storage aspect. So digging a little bit deep on the Windows Server 2012 architecture or SM API itself, you can check that we sit on top of here System Center 2012 SP1. So SM API has, as I was describing, it was a WMI-based API. And then it's a standard-based. Why I say standard-based is, so the whole model is actually derived from SMIS. From SMIS, model is derived, and then we made a high-level API. And then when you call into these APIs, what happens is for the standard-based, we have a standard-based storage management service, which basically converts this WMI calls into a bunch of SIM-XML calls, so that then it talks to the SAN array. That's what it does. So there is also SMP providers, not only SMS provider. You can also build a SMP provider. There are a couple of partners such as Equalogic and Nexan implement, where it's a direct WMI provider which they directly implement SM API itself. And the storage spaces can also be managed using SM API. And then SM API also provides a functionality such as pass-through. Pass-through API, using pass-through, what it gives is direct access to all the functionality from the SMS provider. What it means is, for example, SM API itself does only the block side management, but for NAS, if I want to do file share creation or file stuff, it is the SM API doesn't provide, but there's already providers out there for NetApp and EMC have providers using which you can do it. So that's where VMM uses pass-through functionality and directly talks to a provider to achieve that functionality. So this is much more digging deep, putting everything together. So here is the VMM server using SM API, and using through SM API, this slide I was describing, the storage management service, using which you can manage all the providers out there. So the providers through SMIS, you can see that there could be multiple types of providers. There could be embedded provider, where the SMS provider is embedded in the array itself. And there could be a proxy providers where they're running on another Windows box or another box, and then that in turn manages the array. So here we use the SIM-XML protocol, to manage. So SIM-XML is one option, and then the SIM-XML WMI is also another option for some providers such as Microsoft iSCSI Target implements in via WMI. So these are the different layers we go through to actually manage storage using storage management service. In case of SMP, there is partner provider directly builds this, and then there you can directly access SAN device. So I was explaining on the Hyper-V host side, we use WSMan or WinRM to a bunch of API which I already described. So given these different components, if you want to, for example, I want to debug or I want to know what's going on when you unmask a LUN to a cluster. So when you unmask a LUN to a cluster, first we will be talking through VMM to SM API and SMA storage service to array to first actually unmask a LUN. Once you unmask, once that operation is complete, we will be going to the host and then looking at host SM API to see whether LUN is coming. online or not. And then we use the cluster WMI to go and add it to disk resource. And so the many components are involved to achieve end-to-end functionality. So for this, we will need to know bunch of logging information using which you can do. So one of them is VMM itself provides logging, which John just explained on using the logman. Then what we call is there is a storage management service itself exposes another set of logging in which you can either access using the same logman or a trace view. And then there is on Windows box itself, you can enable something called SimXML tracing. So SimXML tracing will give you anything going out of the system and then what response you got back. So basically you'll have all the VMM calls in a VMM log, then storage service, whatever it does, high level, and then SimXML. So after that point, if you still hit, then we can go to vendor specific logging on a provider machine itself. So there is, to debug anything, we have to, all the 4 logs we may have to look in some cases. So here is a list of logs. I'm just put it up the slide out there. There's a blog from Hector which describes how to set up this logging. One is VMM log is straightforward, which John just explained and showed. And SM API is also very similar logman with a different GUID. And then SimXML is, there are few registry settings you have to do so that you can collect that logging. On the host side, we have again a VMM agent log is very similar. Then host SM API is also WMI based log, so that we can get. And for Windows 2012 and before, you can use VDS logging. And then cluster WMI logs and cluster logs itself for any of the cluster operations, what we did. And then ISCSI initiator and HB API logs. So since we are, one single click involves so many components, so we would need all these logs to sometimes investigate or root cause a problem. Now I'll hand over to Amit, who will give some demo of how to use some of these components to troubleshoot a problem. Thank you.
All right, thanks, Madhu. So let's move to one of our demo boxes. And let's look at the familiar VMM UI. And let's go through one of these storage scenarios that Madhu was talking about and see how we can find out what would have gone wrong. All right, so I have my VMM on this box, and I have a host here. Let's, for a minute, I'll go and disconnect the ISCSI sessions from my host. Now I'll go back to the VMM demo. I have an EMC provider here. I have a single host added. Let's go to the host, and we'll go to the properties dialog for the host. Go to the storage tab, and let's go ahead and assign a new storage to this particular host. Sorry, this is the wrong host. All right, now if you see here, we have the ISCSI sessions already established with the storage array that we are managing, which is a Clarion CX3. Now what I'll do is, I have a LUN created. I'm going to go and try and unmask the LUN to this given host, and we'll see what happens after that. All right, while this job is running, let's look at a couple of other things that Madhu was talking about. He mentioned the number of components that happen or that are used when there is a single click from VMM and what the different log files are. And he referred to Hector's blog, which is out here. So if you look at this, there is a VMM tracing that gets enabled. There's the SimXML log, which gets enabled, which generates a normal text file. And that's the log that happens when the storage service itself talks to the provider with all the request and the response. And finally, there is the actual storage service logs, which the Windows generates for all the logging or all the invocation that happens on their side. While the job is still running, what I'll do is I'll kick off another operation, and then we'll walk through the different files and see what can be done. So I'm going to go ahead and create a new LUN here. Let's call this LUN fail LUN, so that we hope it will fail. And then we are going to kick off the job. Go to the jobs view. Both the jobs are running, and oops, something failed here. Let's go figure out what has happened. So if you look at it in the VMM jobs view, we just give a generic error message saying SMRC not supported. Now this is an error message which could have come maybe from the provider, maybe from the storage service, or maybe something already happening on the system. So let's go figure out what could have gone wrong. Now on this machine, I have already set up storage service tracing. I've already set up the SIM-XML logs. So we'll go into the storage service tracing. And like we said, like John was mentioning, Madhu mentioned, we have trace view, and all these providers have already been registered. We'll go to the storage service, and we look at the actual instance. And we see that there is an create entrance here, and an add storage volume is called, and we are also going to go ahead and create a new instance. Now this guy tells me that all the logs have been generated here, but it doesn't really give me the actual error message so that I can go and debug what has happened. So now I'll go to the next step, which is the actual communication between the storage service and the provider, and see if my provider logs actually tell me something so that I can figure out what might have gone wrong. So I have the SIM-XML logs also being generated, and we'll go here and find out what might have happened. So I'm going to look for a particular element here, which is used when we go ahead and create a new storage volume. So I'm going to see if the call here has been generated. So this is the request and the response that the provider or the SIM-XML logs has, and this is the request response that the storage service and the provider communicate with each other. I see that the call itself has completed with a valid value. That means the call actually succeeded, and what we do is we now query for the job to see what the job status is. So if I scroll down from this point, I'm querying for a concrete job, and we'll go find out what happened to the job's actual value. Now if you look at this is the response I get back from the job, and this is the response that the storage service gets back from the job, which gets returned to VMM. Now if you look at this, there's an error description already mentioned here. And if I go find what the error could be, it actually says that the specified LUN name is already in use. So the reason why this happened was I was trying to create a new logical unit, which already was created on the same array, and EMC array does not allow you to create two logical units with the same name. So now once I've figured this out, I can go back to VMM, recreate the LUN with a different name, and I have easily debugged from all the three logs, and we don't even need to go anywhere else, just figure these out. Let's go back to the VMM box and see what happened to our previous job. So the previous job is still running. Now what's happening is we tried to do an unmask to the host here. And if you remember, we had gone back to the host and we had disconnected all our sessions, right? So what do we expect here? That the job is going to continue, it's going to retry for a while, and it's actually going to go ahead and fail. And when the failure happens, the error message you get is the logical unit is not found. And we have had dealt with a couple of partners where the error message just comes generic saying the logical unit is not found. And they're like, hey, the logical unit exists. I have seen it in the array. I tried to unmask it, but it failed. So what do I do now? So what we tell them is, OK, let's go figure out what has happened. So they look at the storage traces. And like we were seeing earlier, we have the add storage volumes call getting called, which is the actual one which goes ahead and does an expose path on the provider, which means it's trying to do a register to the actual host. This guy seems to be fine, so there's no problem here. Let's look at the SIM-XML logs. And even if I look at the SIM-XML logs, it seems like when I was doing a normal association, everything looks fine, and there is no other error message that has been shown here. I can look at the client storage system, and everything seems to be fine. So what else could have gone wrong? Let's go back to the host now and see if we can figure out what has happened here. Go back to my disk management, and the LUN that we were creating was a 4 gig LUN. I don't see the LUN here. That means the LUN did get registered, but somehow the volume does not show up on disk management. And that's the reason why VMM would have gone ahead and failed, saying, well, we cannot find the LUN. We tried enough number of times. This is the error message that VMM throws. So we go back to the host. We don't find it here. We go back and look at the iSCSI initiator, and we realize, oh yeah, because we disconnected, the LUN does not show up. Let me connect back to the iSCSI sessions that we are using. So I use the iSCSI initiator, connect the session, and as soon as I connect, you see a new disk pop up on the disk management, which is the 4 gig LUN that we were actually waiting for, right? Now we go back to VMM. We say everything is good. We have found out what the actual reason was. Let's try and restart the job and see what happens now. Right? So the job goes ahead. It's trying to find the volume. The volume is already there on the host. So the mounting of the storage is done, and the job is actually going to succeed. So we have also seen a couple of customers who run into these issues, go all the way from VMM, find out what the issue is, look at the logs, go all the way to the host, figure out things, and help themselves to help us. So with that, I'm going to hand it over to Kurt so that he can talk about the Windows networking next.
All right, thank you. So we're a little behind schedule here. I'm going to try and run through these a bit quick. The first thing I'm going to do is try to give a big kind of an overview of networking. There's already been 2 networking sessions, so I'm not really going to deep dive into it. I'm just going to try and explain the interconnectivity of the components so that when you're troubleshooting, you kind of get a good idea here. So you've got logical networks. Logical networks are kind of what make virtualization, network virtualization possible between your hosts. It's your bridge from the physical to your virtual networking environment. And anytime you're setting up a logical network, you'll see a definition of network sites. That's where you're associating your hosts with your logical network. This is where you put in your VLANs, your IP subnets, your mappings of VLANs and their IP subnets. There's the assumption here of connectivity between any of the VLANs you're setting up, and that's not something that's really not really seen to VMM. That's something, the network admin or whatever is going to have some kind of physical device there to do, whether it's the layer 3 switching or some kind of routing there to move the VLAN so that they can communicate to one another when you say that they can communicate to one another. Like I said, that's where you allocate the host groups. And the logical networks are the thing that allows network virtualization so that the same logical networks existing across hosts can have VMMs within them that can speak to each other. And you set up these IP pools on the logical networks. Generally, we refer to these as the provider addresses. They're required for network virtualization so that you can speak between the hosts. The logical switches are the thing on the host, of course, that binds to the specific network card if it needs it, essentially. These consist of port profiles in VMM. They're the thing that kind of span multiple hosts, so in order to set up a logical network, the switches have to kind of line up on the different hosts. And the compatibility definitions for your host NICs, these are where we're going to set up teaming, that kind of thing. So you can't create a logical switch without uplinks and VNIC profiles, but you can actually create those profiles during the creation of the switch. So that's not too big of a deal there. The native port profiles, like I was mentioning, there's uplink port profiles. These are the things that connect the logical switch to the physical host, essentially. They're the host NIC configurations. Teaming, load balancing, that kind of thing, those are all your configuration there. You're assigning your local network. They're the bridge between the physical and the virtual network. So then the VNIC profiles, on the other hand, are kind of going in the opposite direction. They're the thing that binds into the VM. And they're essentially just, there we go. And they're essentially just the VNIC configurations, setting up everything in the VM. Security settings, bandwidth limit, the performance settings like offloading, the payloads and things like that. There are defaults available. I have a note here that bandwidth settings can't be used with signal root I/O virtualization. Just kind of a caveat there. There are default VNIC port profiles available that you can select, and then there's also these things called classifications for ports that you can kind of group a lot of profiles together so that so you're not creating a lot of VNIC port profiles, but also exposing some kind of name that's actually useful to use. So then the VM network is not a Fabric component. This trips some people up because they think they want to find it in the Fabric pane, but it's actually in the VM and services pane because there's no relationship with the physical network really by that point. So if you're setting up a VM network and you choose no isolation, this is basically the pre-Service Pack 1 behavior, where the VNICs are basically attached to the logical switch. It's attached, whatever it is, like you're just setting it up on Hyper-V. And then the isolation setting that's new with Service Pack 1 is essentially how you set up your VLANs in between, or your VMs to talk to each other in between hosts without really being concerned about the underlying topology of the network. Maybe I'm not pressing it hard enough. So in isolation mode, your VMs have their own address space. That's often what we refer to as the CA, the customer address space. By default, the isolations have no external connection. In order for some kind of external connection, you're going to need a gateway of some sort. So that brings us to the connectivity of the VM network, which requires a gateway device. Gateway device is available right now. I know Iron Networks has a gateway device. I'm not sure if it's out yet or if they're just releasing it very soon. I'm not sure on the dates of those. So there's if you don't have your gateway device already configured in VMM, when you create the VM network, you're not going to have the ability to do anything but have no connectivity, meaning that the VMs on the VM network will not be able to speak to anything outside of their VM network. You can set up IP pools inside the VM networks, like I mentioned before. Your subnet was actually, when you create the VM network, you define the subnet that spans that. You can kind of think of VM networks referring to logical networks the same way that VLANs connect to physical LANs, where you've got overlapping IP subnets, and there's some kind of thing that needs to make them talk in between one another. So you kind of divide your range into pools, and then one address is always reserved with the virtual switch. So if you've got a 24-bit subnet, you should have 254 hosts, but you'll get, or 255 hosts, you get 254 because one's given to the 253 rather, because one's given to the switch. So then a quick overview of the architecture. Your VMs sit on top, kind of pulling all this together. Your VNIC profiles then tie those to the VM network. And then your network virtualization, if you're talking between hosts or if you're trying to talk to the outside world, it's a gateway. This is what connects to the logical network. And then your site definition connects those logical network to the logical switch in the Hyper-V hosts. Same logical switch like it's been in the Hyper-V host before. And the uplink port profile is the thing that's defining how those logical switches connect to the physical ports on the Hyper-V host. So a couple notes for the cloud deployment. When you're deploying to a cloud, your VM must be connected to a VM network that's associated with that cloud. That VM network must then be connected to a logical network, and that logical network be associated with the cloud. So if you're trying to deploy to hosts and there's failures because it can't connect to certain hosts that have the ability, that should have the ability to connect to that, this is sort of your progression that you look through to make sure at each step you've got those associations built. All right, so I'm going to, which one was it here? This one here? 3? I'm just going to plug in a mouse here. See if it's awake. Can you log in? I am sharing a laptop here today. We'll see how that goes. All right. So I'm not sure which. I'm connected to VMM2 here. VMM. Do we have more servers here? It is in the process of connecting, I'm told. This does not bode well. Here we are. Okay. One of these will come up shortly. Here we are. All right. So I've got a PowerShell open here that's essentially just a few commands that we want to run. To kind of show you, normally when you're working on some kind of network troubleshooting, you're going to be working closely hand in hand with a network administrator. Unless you are the network administrator, then you're working with yourself, I suppose. And so I'm just kind of show some commands here to get a little bit of information. So here what I'm doing is I'm just getting the network adapters on one of the hosts I have, Hyper-V 13 it looks like. And then I'm going to show the properties of the hosts. And this is something that you could use when network troubleshooting. So we've got the different interfaces here, the physical addresses, and this is information that kind of uniquely identifies the slots in the machine, useful if you're having someone go out there and look for a device. And then this is actually only going to show the enabled hosts on the system. So if you've got a disabled network card on the system, you might have to connect into the system and see that. And then here I'm just showing the VLAN mode of it. So there's the whole access mode, trunk mode thing that you're going to want to make sure you have that all sussed out with your network administrator to make sure that what you're doing is expected of him or vice versa. So that's just a little bit on that there. And then more into, this is connected here. I think it might have been on a different. So here in this script here, I'm going to kind of show what happens with IP address pools. This is another thing that tends to trip people up. So I'm just going to get a pool that, let's see. So I'm going to get, this is a pool named default, and it's essentially just got one address that I've defined, sort of just for the purpose of this demo. So here I'm asking for the available addresses in this pool. I'm sorry, I'm asking for the assigned addresses in this pool, and it's returning just nothing because no one has requested an address from this pool, so it's got nothing assigned. Ordinarily, by default, it's going to send, it's going to show me which addresses are defined. So I'm going to get one of my virtual machines that is running on this, that's managed by this VMM server, and then I'm going to ask for an IP address and then grant it to that specific host, or that VM rather. And so it returned me an IP address, and it tells me it's assigned to this virtual machine with this ID number. So then I'm going to ask to show the pool again, and not surprisingly, it's just going to give me the information of all the assigned IPs, and you see it's just the one that's been assigned. Now, because this pool doesn't actually only has one, I'm going to try and use this mouse. And I'm going to try to request another IP address from the same pool. And we see I get an error message here that says all addresses in this pool have been used. So then I'm going to try and get now here I just asked for the available size property, and it tells me there are no available addresses, as you would expect, since it just told me that. And then I'm going to get the list of addresses. And the next thing I want to do is get all the addresses that are assigned to a virtual machine. And then, now if they were assigned to a VNIC or something like that, then you'd have to use a different commandlet. You see here, to bind the ID to a specific virtual machine, I'm using the get sc virtual machine commandlet. So you'd have to use the proper commandlet for whatever type that it was bound to there. And by doing this, I get a list of addresses and which VM they're assigned to. And if for some reason maybe you deleted the VM out of band or something like that, you might get this kind of situation, and you want to revoke the address manually. So in this case, you can just revoke it by using that the same thing we've done before. And here it returns me the address object again, but this time you see down here marked for deletion is true. So now if I get the pool again, unsurprisingly, it tells me that there's one available address because I've revoked the IP that I granted. So that's, I guess we're going to kind of move into questions now, kind of have an open Q&A session for the last bit here. So if you've got anything, feel free to come up to one of the mics. If you just call out in the audience, it's difficult for anyone listening later on the recording because they won't actually hear the question.
Does anybody have any questions? Come on, somebody? Anybody? Beer time? Thank you very much, guys. Appreciate you coming out.